Welcome to my YouTube channel Kadam Academy. Dear friend, my YouTube channel we have the number of numericals on the undamped vibration, mechanical vibration. Under this we have studied number of theory and numerical parts. Please subscribe my channel for the more updated videos. Dear friend, today's lecture on the rotational unbalanced mass. This is the example for the tail rotor section of helicopter. See, this is the figure. In tail rotor consists of 4 blades, 1, 2, 3, 4, each of mass 2.3 kg. 4 blades are there of each 2.3 kg and engine box of mass 28.5 kg. The center of gravity of each blade. The center of gravity of each blade is shown by this dot here at a distance of 170 mm from the rotational axis here. See, I will zoom it, this diagram, show you this diagram like this. This is the rotor blade 4. These are the center of mass for the blades and this is the center of rotor. So this is the diagram to show you, friend. The tail section is connected to the main body of the helicopter by an elastic structure. The natural frequency of the tail section is observed 135 radian per second. During flight, rotor operates at a 900 rpm revolution per minute. What is the vibration of amplitude of a tail section if one blade of the blades fall off during flight? Assume the damping ratio 0.05. What is the numerical? Here is the blade. I will show you drawing the diagram. This is the 4 blades. This is the rotor with the 4 blades and each are having 2.3 kg, that's the small m of 2.3 kg, and this total engine weight capital M is 28.5 kg. So somewhere here at a distance it's a center of gravity. The center of gravity of each blade at a distance small e is equal to 170 mm. This is a pure problem of the unbalanced, the force vibration or the rotational unbalanced mass. So friend, what is the given to you? The mass of engine, okay, M engine is 28.5 and this mass of blades 2.3. Total mass of tail rotor M we can calculate by adding the addition of these two, 28.5 plus 2.3. This small m, capital M, that is the M engine for this capital M. Okay, this is for engine and this is for blades. This is for one blade, small 2.3, and this addition will become right here. Here written the total mass of the system M is equal to 37.7 by adding the 28.5 plus 4 times 2.3 blades. Number of blades how many there? 4. One blade is 2.3 weight and the 4 into 2.3 plus 28.5 M engine. The total weight of this system is 37.7. The total mass of the tail rotor, that is 37.2. What is also given here? The omega n. Omega n is given to us. Just we can find out this K, the stiffness we have find out here. How to find out stiffness? Omega n is equal to K by M. So omega n square is equal to K by M. So K is equal to M into omega n square. So friend, what will happen here? 135 square means the omega n value is given. Omega n value is given. And into this M, just we have calculated 37.7. This M is capital M. Okay. Here the total weight of the mass. This is 37.7. The total after calculating the stiffness for this with when the total 4 rotors are there, blades are there, then stiffness become 6.87 into 10 raised to 5. Now friend, what will happen? What is also given here? The value of zeta also given 0.05. These are the given data. But what is the ask in numerical? Numerical is there. I will show you. During flight, rotor operates 900 revolutions per minute. What is the vibration amplitude? What is the vibration amplitude, capital X, of the tail section if one of the blades fall off during flight? Assume the damping ratio. Damping ratio we have to assume. That value is also given, that zeta is equal to 0.05. Friend, here the blades are there. So what is asked in the numerical? If this is the before condition, after this is the rotor, this is the blade, this is the another blade, and this is this cell blade. Suppose here is the center of gravity for this blade, and it is balanced by this blade, and the center of gravity of this blade is not balanced. One of this blade is get removed or it get fall down during the flight. So this blade is not balanced. These blades are balanced, but this blade is not balanced. This is the after condition. This is the condition after fall down. So what will happen here? This one of this blade is fall down during the flight. So what will the value of X? What we have to find out? What is the value of X amplitude in that case? How to find out? I will show you. So friend, in this case, what we have to find out? X. How to find out then? Here the M already we have calculated, value of M, but by considering after falling of this one of the blade, what is the M? So that I will show you. That M is, I will represent as a M dash. Here M we calculated. How we can calculate here M? M engine plus M blades. So similarly we will calculate here M engine 28.5 plus blades. Now blades are not of 4, 3 into 2.3, and then this multiplication, the value becomes 35.4 kg. So this is the answer for this M dash. Okay, the M dash is nothing but the weight of this system, total system. Now one blade is removed. That means unbalanced weight is how much? Unbalanced weight is represented by small m. Okay, so I will write here small mo for m or small mo, or you can write small m also. This is the unbalanced weight mass. Okay, and that will be 2.3 kg. The 2.3 kg is the unbalanced mass. So what we have to find out? We have to find out how to find out X by using the value for rotational condition. We have to find out. But what we are going to do here, already we know this E. E is also known to us. Here E is 0.17 meter. Here written 170. E is how much? This is the distance from this. This distance is E. Means distance of the eccentric or center of gravity from the center of rotation. Rotational axis. Rotational axis, it will rotate like this. This will also rotate like this. This blade is rotating like this. But if one of the blade is removed, what will the value of X we have to find out? So friend, now by using this the formula, we can also find out the omega n. What is the value of omega n? We have to find out. Here we will write this omega n dash is equal to under root of k by m. Here m dash. Okay, and in this case k, value of k already we have calculated 6.87 into 10 raised to 5 Newton per meter. we have to assume this k is not going to change, m only change. K is not going to change, only m going to change. What is the value of omega n? We have to find out. Then omega n dash is equal to under root of this k is 6.87. We have just calculated into 10 raised to 5 upon the value of m dash is modified value after the removing fall down of this one of the blade. Omega n dash become, it will going to increase. Why? Because m dash is reduced and this omega n dash m dash, they are in reciprocating. Okay, they are inversely proportional. That's why the value is increased, and I will write here value after calculating on calculator 139.31 radian per second. Due to this inverse proportionalization, and also we can find out the value of the r omega by omega n. What is the value of omega? Omega becomes 94.25 upon 139.31. Friend, what will happen here? R becomes 0.677 and zeta is also known to us. That value is given 0.05. 0.05. So why I have written here? Because we know the formula to calculate the amplitude for these rotational unbalanced masses. We can find out by using this formula. This x is equal to, we can find out here and write the formula E MOE by M, which is equal to r square upon under root of 1 minus r square bracket square plus twice zeta r square. In this case, this MO means the unbalanced mass and this M is total system mass after the removing the fall of this one of the blade. Here that is the m dash. The value is 35.4. I will put all the values. MO is 2.3 and E is 0.1. How much? The value of E is, we'll say 17 upon m dash is 35.4, which is equal to, inside here r square is how much? We are calculated 0.677. So 0.677 square upon this 1 minus r square means 1 minus 0.677 square bracket square, okay, plus 2 zeta r. 2 zeta r, here I will write the 2 zeta r. 2 zeta r here. What is the value of 2 into zeta is 0.05 into r is 0.677. So this value becomes 0.0677. Putting this value 0.0677 its square. Okay. So this x becomes value of this x after solving this and putting calculation price, the value of x become, I will write here value of x. Just I will make a line to clear you. The value of x becomes, directly write, the 9.24 into 10 raised to minus 3 meter, or x is equal to 9.24 millimeter. This is the value of x. Okay, so friend, so this is the amplitude for when the one of the blade is fall down. So naturally the amplitude of this will be, the frequency is higher than the lower the frequency with the 4 blades. See here, the omega value 139.31 is greater than this value in this case here, what is the value given to us? That omega n is given, where we'll calculate by using the, what is the value is given? 900 rpm. So omega n for 900 rpm into 2 pi by 60. So we'll get the value of omega n becomes 94.25 radian per second. So what is the comparison in this both the one? This omega n and this omega here. 139 is greater than the 94 omega n. This omega n dash, when the blade is removed, the increase in frequency, it will show increase in the frequency, and you can see the frequency is here 94 with the 4 blades, and when omega n blade is removed 139.31. so that will be create a higher increase in frequency. So this is the numerical. So thank you for watching my video. Please subscribe my channel and share it more. For updated video, click on the bell icon. Thank you very much.